Hello my loyal subjects and welcome to a brief discussion of how we are going to actually program our physically based shader. And by program I just mean build it with nodes, but of course we're setting it up and, you know, this is in a way programming. So first and foremost I want to talk about the actual surface shader we're going to be building. In this case I'm going to stick to a very simple physically based shader. We're going to stick straight to the concept of an object can either be diffuse or reflective. It can have variable amounts of that, but we're not going to be worrying about things like clear coat or glass or anything like that. For now, maybe I'll cover that in the future if I get time. If you have not watched the previous videos in the series, please go back and watch them because I do cover these subjects a bit in depth. And so yeah, anyway, let's start it off. This is how you build the actual shader. Now, I'm going to go over it again. First of all, we're going to need diffuse, of course. We're also going to need a glossy for the purposes of our reflectivity. And then we're going to use an add shader because this allows us to determine how much diffuse and reflective light it has without having to constantly fight a mix factor. The mix factor is fine in a simple approach, but as you get into more complex materials or more variable materials, it doesn't really work as well. So we need to actually be a little bit more careful in that regard. So add shaders both allow us to break the laws of physics, but they also allow us to enforce them ourselves and create our own rules to enforce them. And that's exactly what we want. So anyway, that is the shader part of it, and I'm just gonna one thing that you might want to start doing is cleaning up your graph. So I'm gonna hit Shift P, which is the this little node wrangler shortcut. This will box it in. You can also go to add frame, but I'm going to label this and I'm just going to call this shader. I have caps lock on. Shader. Maybe with an S. Shaders. And I'm going to make it kind of a, we'll make it kind of a yellow. It's like a shader color. Or maybe we'll make it green to match Blender. So, anyway, there, that's that part done. Now we need our inputs for the shader itself. First thing we're going to do is we're just going to set up and decide what our inputs are going to be. These will be a color, two colors actually, a diffuse and a reflectivity, which we're just going to call diffuse and specular. Specular being the lowest reflectivity of the surface. As I explained in my previous videos, we can deduce the rest. And then we're also going to need a roughness value, which is going to be our final sort of controller here. Roughness. And we're going to set that to maybe 0.1 to begin with. I'm just going to punch in some values that I know look decent. Just kind of estimating here. And as you always should, Shift P. And then we're going to go up here and we're going to say inputs. Now the reason why I'm not turning this into a node graph just yet, you know, or a custom node group, rather, is just because Node Wrangler is not the best integrated when it comes to groups. Like, this whole Shift-P shortcut doesn't work in graphs. You can still go to Add, Layout, Frame, but it just doesn't work as well. So anyway, inputs, let's just make it like that color. Anyway, so that's the inputs we're going to mess with. We'll probably have some other ones, but for now, this will be it. And for now, what I'm actually going to do is I'm going to zoom out and connect these up. Diffuse to diffuse, specular to glossy, and roughness, of course, to roughness. If I can properly drag the line over. Now, you can hold down Shift and add a relay if you drag over some lines. This will allow you to add another relay and therefore make this a little bit cleaner to read. You can hit Alt-P, by the way, if something gets caught in a frame. If you left-click on a frame, if your mouse left-clicks on a frame while dragging any node, and a relay is a node, it'll put it in the frame. If you want to remove it, you just hit Alt-P, like unparenting something. And of course, if you want to move the entire frame, you can do that. In this case, I don't mind it necessarily being in the frame, so I'm just going to click on the frame. And yeah, anyway, that's the thing. Next, we need to do energy conservation. This one's relatively easy. Just the more reflective an object is, the less diffuse it is. And you could refer to this as ducking. That's a good term I heard for it. You know, the higher one value gets, the lower another gets. So let's go in here, let's add a mix color. We want to multiply. And multiply, of course, if you remember, produces a darker value the darker the second input is. That means that if we want to have more reflective objects become less diffuse, we actually need to invert our reflectivity. So when we have less reflectivity, this multiply will receive a brighter value, a brighter result. You know, you can see a very dark reflectivity results in a very bright value out of this invert node, and therefore multiply produces a very bright value. And I'm just Control-Shift clicking to preview nodes. And then, as always, Shift-P, energy, actually I'm just going to call this one duck. And let's just make this yellow. Let's drag it over here. And make sure it's not getting caught in the shaders. Anyway, I'm also going to add a relay here just for slight clarity. And yeah. Next we have our Fresnel. Now if you remember, our Fresnel was a little bit complicated. This one will be a little bit on the complex end. So let's go. We need our facing angle, basically how much it's facing us. 0 if it's facing us, 1 if it's on the edge. And it's just a linear gradient. In this case we want a kind of downward curve. A good number I've found is putting it to the power of 5. 4 or 5, I've heard it both ways, but I personally prefer 5. Or 4, actually, you know, I don't know, it depends. I'm kind of in a 5-ish mood this way. 5 I think is slightly more physically accurate, but either way, not a huge deal. So I'm just going to unparent those, and let's put them in their own group. I'm just going to call this Fresnel, and of course Fresnel should be purple, because purple. So anyway, so we put it to the power of 5. Now, there is a little bit of a tweak when it comes to roughness in this regard. So anyway, the whole Fresnel effect is the idea that objects become more reflective at grazing angles. We're going to add this in its own little separate segment. For now, I just kind of want to keep this over here. I'm actually going to move this behind the inputs, and you'll see why later on. Hopefully. It just is a decent layout I've found with this. So, next, we're going to build up our reflectivity, what our final reflective value will be. And, yeah. So if I go in here, we need to mix a color. Because the more of a grazing angle we're at, the more I want, the more of a grazing angle we're at, the more I want it to use white as its color. You know, its reflectivity. Just very, very bright reflectivity. However, this is not always the case. Because the more, one second, let me just go over here and look at the shader. The more rough a surface is, the less of the Fresnel effect it has. But essentially think of it like our specularity is the lowest amount of reflectivity that it can have, the least chance. You know, if it hits dead on, that's the lowest percentage chance of something reflecting off, and it just gets higher around the edges. Well, as it becomes more rough, it becomes more likely to just hit dead on. So what you do is that you mix it based on roughness. But sadly, we can't just use roughness. We actually have to use the root of roughness. This is a little bit mathy, but essentially, what we have to do is, and I'm just kind of adding relays as needed, what we have to do is we have to put this to the root of whatever value we used on our Fresnel curve, so that it can counteract it. Now, sadly, there is no root math equation, but there's a way to do it with power, which is 1 divided by. So if I go divided, it's 1 divided by, in this case, 5. We put our Fresnel power is 5. So to counteract that, we need to put it to the root of 5. Sadly, since there is no root, we have to do a 1 divided by trick. It's kind of similar how with you can do the process of division. You know, you can get the same result as division with using multiplication. So, for example, let's say I wanted to use multiplication, but I wanted to get the same result as dividing by 4. Well, what you do is you take 1, you divide it by 4, and that's what you need to multiply by. In this case, 0.25. Multiplying something by 0.25 is the same as multiplying it by 4, or dividing it by 4, rather. If that doesn't make any sense, just trust me on the math here. We need to add a value. In this case, our Fresnel power. I want to make that 5. We'll plug it in there. And we'll say 1 divided by. This is the value we need to put it to the power of, basically the value we need to put it to the power of in order to create a root effect. I know that's kind of weird and mathy and horrible. I get it. But it makes it so that as I increase the roughness, that Fresnel effect disappears very quickly and then fades off more slowly near the edge. So, anyway, that's a thing to think about. Pops in very bright at the last second. And yeah, that is the Fresnel kind of specularity-ness. And as you can see here, very pretty looking. Now if you remember my metallic video, I talked about the difference between metallic and non-metallic surfaces. So in this case, this is a non-metallic surface because it's grazing strong Fresnel, low specularity, and high diffuse. If I wanted to make a metallic surface, I would remove the diffuse, and you can see it's already starting to look like metal, and I can either have high reflectivity and also colored reflectivity, whereas non-metals cannot have colored reflectivity. This will properly handle roughness. So as you can see here, I can increase this, and we get a nice roughness to it. Let's make that red, and then we'll drop our reflectivity back down to a human level. And that is our, it's like a cloth, very high roughness, because cloth is of course woven and very bumpy, and as we reduce it, you can just see it works correctly and very nicely. And that is your physically based shader. Now we need to clean it up a little bit, as always. I'm just going to select this relay because it's pointless and hit Control-X on it. Control-X will get rid of it without necessarily, it'll try to connect up all the lines. Tries not to break your node graph. I'm just hitting H, by the way, to minimize these nodes. Select them, Shift P, and I'm going to call this one Specular. And I'm also going to name some of these nodes so it's a little bit clearer. I'm going to call this one Fresnel, because that's of course applying Fresnel. Roughness, Fresnel, roughness, and I'm just going to extend that out a bit. I'm just going to drag a relay around, because why not? And yeah, that's our graph right there. That is our entire graph. I'm just going to dump this in its proper place. So yeah, there we have a nice graph, and set it all up correctly. Let's create a nice orange. And yeah, anyway, so these are, this is our graph here, and next we will talk about actually turning it into a node graph. Okay, so the next part, of course, is that we're going to add the node graph. So let's select all this. Let's hit Control G. This will add it to a nice node group for you, and we now have this new node group input, and we also have group output over here, which should really only output a shader. So anyway, we have this group input. Now notice, we're going to start replacing our inputs over here. So we have this whole inputs group. We don't need that anymore. There's a cool trick if you don't feel like going over here and finding where to plug it all in. You can add a relay with shift drag, and then drag from the group input into that relay. This will redirect it properly. And you kind of have to fiddle with it a little bit to get it to recognize it. And then you can delete your input. Let's name that. Just while we're here. Diffuse. And then we'll do the same thing with specular. Let's add it. Let's call this one specular. And then we can delete that, and then we'll do the same thing with roughness, where we'll drag it over and snap it. And then we'll go roughness. And we just delete the entire inputs group and drag this in there because this is now our inputs group. And to be honest, well, I suppose these relays should stay for cleanliness purposes. So anyway, that's our thing. Oh, this was renamed roughness. I actually want to name this specular. And then this should be roughness. And I also want to set it to a range of 0 and a range of 1. Simple enough. And yeah, now we have a custom shader. I'm also going to rename it to surface, because that's what I like to call them. You can call it whatever you wish. I'm just going to call it surface, and then I'm going to say that I'm using the specular workflow, which I'm just going to call spec. Now there's another workflow we can use, another set of inputs that are just as physically accurate, but are slightly easier to use, because of course this has a bunch of fiddly rules that you need to follow. They can be a little bit difficult to actually obey at times, and there's one other one that's a little bit more, makes a little bit more sense logically. However, I want to do some things first. First, I want to actually expose some more information. We have some information in here which we're not exposing. The normal, which you need for like bump mapping or layered materials, like different materials that have different normal maps, even though they're layered in the same material. Displacement, sadly, is applied to everything. So if you ever want to just apply it to one shader, you can't. Unless you use normal, which is very flexible in that regard, even if not as high quality. So anyway, I'm just going to zoom out and drag this over here as an input. I'm just going to add a relay as well. And connect that up here to the diffuse. So now glossy and diffuse normal is connected up as a nice little input. So, and for the sake of not having a wire that runs entirely across your graph, I recommend adding relays and variously shuffling stuff around. Anyway, so that's how you add it to a graph. Next, we're going to clean this up a little bit so it's easier to make variants or different kinds of materials like clear coat and everything as we go. First of all, this Fresnel group, let's hit Control-G, turn that into a node group. And yeah, pretty much in its current state it's fine, except I just want to say Fresnel and Fresnel power. Simple enough. And yeah. I don't know why that has a 0 and a 0, but whatever. I'm going to assume it works, because it is working. So, anyway, I'm just going to call this one... in this case, one of the things I like to do is any nodes that are just for the physically based, making physically based variants, what I do is I use PBR dot, and I use a little period to indicate it. So if I zoom in here, it's PBR dot, in this case Fresnel. Just relatively easy to immediately say, oh, hey, this is a node that is not meant to be used in your materials. This is not a shader or anything. This is literally just an internal thing. I should honestly look up, because it's alphabetically sorted, I'm pretty sure, how to get it to appear at the bottom. So that it's less obnoxious. But anyway, I imagine it's like if you put a number, a dash, or something. Let's actually see there. So if I go to group, oh yeah, well I can't nest groups. So group, nope, that puts it right up near the top. So anyway, let's see, underscore. Nope, that still puts it very near the top. Anyway, I'm going to fiddle around with that and find out which one's correct. Either way, now we're going to need specular, basically plugging a certain amount of specular and getting a certain amount out. So we're also going to need Fresnel values, etc. So, actually, this will be... I suppose this will be Fresnel will be part of the specular. So I'm just going to select everything that I need from that, and I make Control-G. And let's figure out what our what information we're passing around here. And also I'm going to rearrange these. Remember, you can use the same modeling controls, such as scaling and other transforms and so on. It's all relatively easy. So, so in this case, we have roughness, we have specular going in, so I'm just going to call this one spec. Or specular. So that's how much you want, and then we're also going to have over here... Oh, that actually renamed it, not label. Sorry. keep forgetting that name and label are different things. Also, that's literally naming the node. Never mind. I'm an idiot. Group input. Anyway, so if we go over here, specular. See, I'm not incompetent. And roughness. I'm just going to say the minimum is 0 and the maximum is 1, just for the sake of simplicity. And, yeah, if we go over here, I don't think we need to feed out a roughness, to be honest. As we don't change it at all, I'm just going to call this one specular. So specular in, specular out. And I'm just going to call this one pbr.specular. This is all our calculations. I'm hitting this little F, by the way, to save it. This will make sure that it has a fake user, so that it is saved no matter what. Basically, Blender will delete anything that's not being used. So we're saying, hey, we don't care if no one's using this. We still want to keep it. It shouldn't be a problem, but I just do it out of habit for anything that I really like and want to keep. So, matter of fact, I'm going to go over here and select that as well. And yeah. Delete and wire everything up. So, you can also hit H to minimize, which is a good idea, by the way, to keep your graph clean. So we now have a little specular node. The idea being, you plug in a specular value, you plug in a roughness value, which are the two things it mainly needs. It figures out the Fresnel, it figures out you know, everything that you need to do to actually counter that and get the proper colors and everything, all relatively easily. And yeah, just works from there. Next, moving on, we have this whole doc value. This one's really easy. You just select it, hit Control G, and we have the top value. This is our actual value, and then our duck value, which of course, the higher that is, the lower our final result is. So I'm just going to call this one pbr.duck. So duck one value by another. Simple enough. And now notice our shaders looking a lot cleaner. It's minimized. I'm not going to... the shaders themselves are so you're not going to use them over and over again that I'm just going to leave that. And of course this kind of brings us back to the raw concept of what we were doing here, which is that we calculate how reflective our object is at any given point, which takes into account like Fresnel and everything. This is probably the most complicated bit of it. You know, it's like, okay, well we need to figure out how much, what our ratio is of grazing reflections, and then we actually need to figure out, you know, we need to make sure that we have the right color and everything, and that requires some fancy math. But once you get out of that, it's like, okay, the more reflective it is, the less diffuse. And that's it. That's the entire thing. That's our entire shader right there. So, just to review, actually, let's close down our graph and make sure everything works first. And I'm just going to add a little bit of specularity, and you can see it already starts looking better. And let's go up here. And if we start making it rough, you can see it just, like, there's never a point where it looks really incorrect or horribly incorrect. It just kind of looks correct throughout. So this looks like kind of a cloth or a velvet or something. Maybe not velvet, but, you know, kind of clothy or sandy or something. Then if we go here, this is kind of similar to what Disney's shaders do. But again, we're going to work on a better workflow in a little bit later. But yeah, I mean, this is what we need. The only thing we need to do now is we need to go in and set some decent defaults, because our defaults suck. So I'm just going to set our diffuse color to sort of what Blender usually has it at, which is about 0.8 in each color value. I want about 4% reflectivity, which I'm actually just going to call, I'm going to make it 0.04. I'm just going to hit Control C while hovering over it to copy, and then paste into the other two by Control V-ing over them. Our roughness, that can stay where it is. Normal, stay where it is. Anyway, that's the entire thing, right there. So yeah, that's the thing. That is our physically based shader, right there. In all of its glory. Matter of fact, if I deleted it and pasted it back in, And I can go surface, spec, plug it in, and boom. Let's talk about why these, I just kind of want to show why these are actually really awesome and really useful real quick. So it's like, okay, well I want a kind of, let's say I want an orangish plastic. So I'm going to sort of select an orangish color. Now let's make that kind of brighter. And about 4% is good. And I want it to be a little bit rough, so I'm going to, you know, maybe this is a little bit more of a well-worn piece of plastic. But you can see, right there, boom, plastic. Looks like plastic. Looks like a weird piece of plastic, mind you, but still plastic, nonetheless. Let me just sharpen out the edges, it'll look a little better. So again, this is kind of how you make a physically based shader. This is the result. It's very, very useful. I recommend making one. And then maybe later on I'll talk about, yeah. Well, actually, before I go, let's talk about making a metallic, a base color metallic workflow. So I'm just going to hit Control-G on this surface spec, because we're just going to be feeding it inputs. So our input scheme is a little bit different with this. I'm going to delete that. And I'm going to duplicate roughness. So we have 2 roughness now. I'm going to name this one metallic. What this basically says is, I described previously the differences between metallic and non-metallic surfaces, and how they have different rules. This essentially is built on that model, and this is kind of what Disney uses, and I recommend using it because it's really fun. It's not perfect, but it's very fun. So, in this case, we have metallic, and we have base color. Base color is literally the color of the surface. Now, if you remember the rules of metallic and non-metallic materials, what we can actually say is, we're going to add a color mix node, and we're going to add our metallic value as the factor. So when metallic is 0, as in it's not a metallic surface, we want, we want to use our color in the diffuse. And when it's 1, we don't want any diffuse whatsoever, so we're just going to plug in our second color as black. Now, we're going to add another mix node, also controlled by metallic, but in this case, we're going to actually have about a 4% reflectivity. And when it's metallic, of course, metallic objects can have a tinted reflection. Therefore, our color should be applied to our reflection instead. So in other words, if you look down here, when it's metallic, we use the color to drive the reflectivity, the reflective color, while when it's not metallic, we use it to drive the diffuse color. Because both, because it's kind of a flip-flop. When it's metallic, you already know what the diffuse is. Like, the diffuse is not variable, it's just black. Or very, very, very dark. However, when it's not metallic, we already know what the reflectivity is going to be. It's going to be about 4%. Now, technically, there are situations in which this is not true, which is why I actually recommend adding another value input here. The situation is that sometimes you have a non-metallic surface that is more reflective from stuff like water being put over it. And while I would recommend using like a clear coat or something for that, there are certain times where you want a specular amount. So I'm going to add specular. This is basically how reflective our object is. I'm also going to set our minimum to 0 and our maximum to 1, just because it makes it slightly easier to edit these. And about 4%, 0.04 is good. I'm just going to plug that in there. So anyway, it's going to blend from when it's not metallic, it's going to use our specular value, and when it is metallic, it's actually going to use our base color. That's a proper Disney BRDF style thing, or Disney input style. So I'm just going to call this one surface, and I'm going to say metallic. And we're going to check that little F to make sure that it sticks around. Now let's play around with this a little bit. If I go and flip it to metal, you'll notice it suddenly looks like a metal, regardless. And if I flip it down to 0, you can see it suddenly looks like a plastic again. If I remove roughness and make it very smooth, it looks like a very smooth metal. If I make it like a very rough metal or whatever, or at the very least like a semi-rough metal, and then I can go, hey, well, no, it's back to being rubber or something. I can change the color to like red, and I can be like, okay, well, I want now I want it to be metallic, so boom. This is also relatively easy to use images for. It gives you a bit more artistic control. So yeah, anyway, that's how you make this a metallic shader. And yeah, that's our whole setup. So just to review, in here, just when we kind of decide what our values will be when it's metallic or when it's non-metallic using just two mixed nodes. When it's not metallic, it uses whatever specular value we set, in this case 4%, and it uses our color to derive the diffuse color. When it's metallic, it uses the color to derive the specularity and just says, hey, the diffuse is black. So anyway, that's a little bit simpler to work with, but you still have this diffuse specular if you absolutely need it. Anyway, let's go ahead and let's save the file. I'm going to go to my resources, Blender, and I'm just going to say PBR tutorial. And I just recommend calling yours PBR or something like that. And I'm going to give Blender a second here to save. My Blender copy's been a little bit slow on the saving lately, kind of freezing up. Just give it a second. And then what you can do is you can actually append in or even link. You can link with, I believe, Control-Alt-O. I want to double check that in a second. So, for example, if I went and opened a new file, then hit Control-Alt-O, and navigated over to wherever I saved my physically based shader, I can click it, and there's a little node tree folder. So, we click on the PBR tutorial file, it'll open it up, and you can see all the different bits of it. I can see models, I can see everything, and you can see here we have our nodes. Now, it'll also import any nodes required. So, for example, Surface Metallic requires the other nodes to exist. So if I just double click that, and let's just say I add, I don't know, polysphere or something, and if I crack open the node editor by clicking on this top right hand corner to drag out a pane, you can see these little lines. You can quickly drag those into a direction to split a pane. You can click and drag it to kind of towards one of the windows that already exists to collapse it. You can right click to cancel. I'm going to add a new material, delete my diffuse shader, and then I'm just going to go in here, group, and you can see my nodes in here. Surface, metallic. That's the one I want. And if I just add a, let's just say sky texture for the sake of simplicity, 5 brightness. And yeah, there. That's our physically based shader. I want it to be metal. Maybe a little bit rough. Or super sharp. So anyway, but yeah, you can play around with that. It's a really artistically driven shader, quite flexible, quite powerful. Anyway, enjoy, peace out. I'm tired. I'm gonna go do things now.